Alrighty, y'all. Today we're taking a look at question 4 for Recitation 11. And for this one, it's asking for the capacitance of a system of two metal balls with given radii, and the center is separated by the centers are separated by distance b. So here are two balls, two metal balls separated by the distances. So we're just gonna arbitrarily assign. This one's gonna be plus q. This one's gonna be minus q. And so that we can get the potential difference between them. Because we're finding capacitance, we're going to find the capacitance of each of them, but we have to use our Q over our delta V, right? So we're trying to find the delta V between the two. So our potential for this ball, right, that's going to be our, if we're just doing our integral, right, the radius, R, that's going to be the 1 over 4 pi epsilon naught, and then that's our Q over R. Because again, if we take the integral, because it would be the integral of like ke q over r squared, right? So we're just taking the integral with respect to r, and all that is, that's what's going to give us, get rid of this negative and give us this equation here. So that's that, and then we also have to include, since we also have an effect, there's this ball and there's also the effect of this one over here. We have the 1 over 4 pi epsilon naught negative q over our radius for this first one is going to be a, because again we're looking here, so our positive q, right? So the distance for this one is going to be b. Right, so this is going to give us our voltage for our ball 1, right? And then for the second one, it's the same thing, but instead we're going to use our negative q over a for that radius, plus our 4 pi epsilon naught with our positive q over b here. And that's going to be for the second ball over here. So we're going to get our delta V, and essentially since this B, it said that this B here is really big, it's bigger, it's a lot bigger than A. As this denominator gets really big, this whole fraction is going to go to 0. So you can kind of just like ignore those right now. So what we're going to do, since we're finding our potential difference, our delta V for that, well, really the equation is just Q over V, but we're looking for the delta V between these two spheres because that's the capacitance of the full system. So we're going to subtract, right? So we're going to go from 1, 4 pi epsilon naught Q over A minus this one here. So that's this one here, that's this one, minus our 1 over 4 pi epsilon naught negative q over a. Okay, so the negatives are going to cancel out, and that's just going to become positive. So if we're adding the same thing twice, it can just be 2 over 4 pi epsilon naught q over a. The 2 is going to cancel there and just become 2 there. So this is going to give us our voltage for this system. We're still just trying to find the capacitance. So that's going to be C equals Q over all of this. So simplified, that's just going to look like Q over 2 pi epsilon naught A. And I'm just going to shuffle these around. You can cancel the Q's in the numerator and the denominator. And then since this is in the denominator, that just flips on up. So that's going to give us our final capacitance of 2 pi epsilon naught A. Alrighty, so I hope this was somewhat helpful. I know we went over this a bit in lecture the other day. But let me know if you have any more questions about this one or about any other problems that you want me to try to explain, and I'll do my best to explain them because I guess Sydney explains stuff.